Welcome to the Professor's DuBois channel. This is Professor Corey, and what I want to do today is take some of these solution concentrations, some of the more challenging problems, and try to break them down and give you a method for solving these, because these can be extremely frustrating and challenging, but I have a method that I think is very effective, and I think I can help you with this. So I've got a couple problems, and I'm just going to kind of talk through them and use my logic for this. So the first question says an aqueous solution. Now, aqueous is a key word here. And, we have to know the language of chemistry. Aqueous means that this solution is in water. So my solvent in this case is water. And I have a concentration. It's a percent by mass. So percent by mass ethanol is 6.00%. What is the mole fraction of the ethanol? So this is really tricky, but let's start with that percent. So the formula for percent by mass, or the mass percent, is the mass of the solvent, ethanol in this case, over the mass of the solution, which is ethanol and water, times 100. And I didn't write my times 100 in there. I should have in that upper right. So you can write that in on when you're taking notes. How about that? So another thing I'm going to do here is I'm going to take that 6.00% and I'm going to divide by 100. I just want to get rid of the 100. So I can say, well, 6.00% is the same as 0.06. That's like the decimal percent. And 0.06 is the same as 0.06 over 1, right? I can divide any number by 1. It doesn't change the number. But what I've done is I've created a fraction here where I know that in the numerator, my value is 0.06 and my denominator is 1. So what do I mean by that? I mean, I can say that my ethanol is 0.06 grams and the water must be 0.94 grams because the ethanol is 0.06. If the water is 0.94, the sum of those would equal 1. So I've just got my masses for the from the percent mass. I got the mass of both the solute and the solvent. So the question asks for the mole fraction. I'm going to take mole fraction and write out the formula. Mole fraction is moles of ethanol over the moles of ethanol plus the moles of water. I have grams of each, so I can use the molar mass and calculate the moles of ethanol, starting with 0.06 grams. I get the molar mass from the periodic table, and I do the same thing with water. So I go from grams to moles into the mole fraction calculation. And this approach is, it works pretty well. And I'm going to do a couple different types of questions, and you'll see there's kind of a repeating pattern to this. So let's go on to the next one. Now I've got a mole fraction of ammonium chloride in an aqueous solution. Again, aqueous solution, that means that our solvent is water. I have a value. Well, let's start by writing out, well, what is mole fraction? I mean, what does that mean? Well, that means we have moles of ammonium chloride over the moles of ammonium chloride plus the moles of water. The value, 0.0579, well, that's the same as 0.0579 over 1. So I can say I have 0.0579 moles of NH4Cl, and in the denominator has to equal 1, but the moles of NH4Cl is 0.0579. So if I go 1 minus that value, I get the moles of water, the 0.9421. So now I have the moles of both the ammonium chloride and the water from that mole fraction value. The question wants to know the percent by mass, so I simply have to take the moles, use the molar mass, and convert them to grams. So the percent by mass is going to be grams NH4Cl over grams of solution. That's going to be the grams of NH4Cl plus grams of water, and then times 100. This one is a percent. So same approach. I break down what they've given me. I write out the formula. I take the value, and I can put that value over 1, and now I have a value for the numerator and the denominator. And I can use the periodic table and the molar masses to go between grams and moles. Makes this quite easy. Let's try one more. This one we have a molality. Molality is the odd one because the denominator is just kilograms of solvent, not solution like most of them. But we'll get there. The molality of ethanol in an aqueous solution, again in water, is 9.98 molal. What's the mole fraction? Well, I can take that 9.98 and put it over 1, but it's smarter to, get away from that lowercase m and write out the units. So that would be 9.98 moles of ethanol over 1 kilogram of water. So it's the moles of the solute over kilograms of water. So again, now I've got moles of ethanol. I have a mass of water. What are they asking for? They're asking for mole fraction. Well, what is that? Mole fraction is moles of solute over moles of solution, which is ethanol and water in this case. So I can write out that formula. I already have my moles of ethanol, and I just have to take the kilograms of water and convert that to moles. So first I'll go from kilograms to grams, and then I'll use the molar mass of water to get the number of moles. So it's a real standard approach. It'll work for all these types of problems, and I'm sure you can grasp it really quick. But what's really, really important is understanding what the units are for these different concentrations. So if I have a molarity, that's moles of solute per liter of solution, right? So I have to know all those. And again, I've said this before, I think these concentration units are good to use flashcards. Really understand what the units are for each. Know what mole fraction is so you can write it out. And the key thing here is that we can take any number and divide by 1, and we haven't changed that number. And we can really use this to our advantage because these all end up being fractions, and we can have 1 in the denominator. So I hope you found this video useful. If you want to do me a big favor, you could give it a thumbs up. Otherwise, stay tuned. More coming. Professor DuBois channel.